concept central to SAGES is that the Earth operates as a tightly coupled, dynamic system. It is our life support system, and it is controlled by a complex arrangement of linkages and feedbacks within and between the oceans, atmosphere, biosphere, and the solid Earth. Recent human activities such as fossil fuel burning and deforestation are dramatically increasing atmospheric concentrations of carbon dioxide. The impact of such an increase is not known with certainty, but the increasing global temperatures, frequency of floods and drought, and the rising sea levels are typical of a system undergoing change. The advancement of modern technology, particularly satellite observation and the capacity of computer processors to handle, distribute and display massive data sets, is driving our understanding of the Earth system forward. Our ability to perform complex modelling depends on consistent data on a global scale. The creation of SAGES is the response of a group of scientists to improve our understanding of how the Earth system works, and to improve our predictions of its potential response to human-induced changes on both global and local scales.
SAGES is the Scottish Alliance for Geoscience, Environment and Society. What it is a group of scientists in 9 universities that are pooling their resources and their skills to try and understand better how the world's environment works and its interaction with society. The world's environment can be seen as a system of interacting parts. The different parts are very familiar. That's the land surface, the oceans, the atmosphere, the ice sheets at the poles, vegetation and humankind. And traditionally, we've looked at each of these in isolation, and this has been very successful in understanding how the different components work. But what's become clear with the problems of global warming and the impact of human activity on the environment is that we don't understand the interactions between the different components. For example, if you want to understand how the Antarctic ice sheet will respond to global warming, you have to look beyond the ice sheets, specialists, and to look at the way the ice sheet interacts with the atmosphere and the ocean temperatures and sea level change. SAGES is an investment of over £22 million. It's invested by the Scottish Funding Council and the different universities, and the key proposition is to create 30 new scientific posts, and these fall into 3 areas. One area is simply to reinforce those things that we do well in the individual disciplines, and here we have 3 themes. We're looking at the land surface, at the carbon cycle in relation to vegetation, and oceans, atmosphere and climate. The second area is to look at the links between these, and to do this we're creating a Centre of Earth System Modelling. And this modelling activity will focus on the links between the systems and improving the understanding and the prediction of what will happen given certain changes. And the third group are those concerned with the link between society and the science. We're interested in the two-way interaction with the scientists responding to the needs of society and the science is providing a more accurate information which can be used for policy formation and business.
We're living in a really exciting time for our science in Scotland. It's exciting for several reasons. One is we have fantastic capability, world-class capability in understanding and analysing rates of landscape change. We also are being confronted with very, very big questions about how the landscape will respond under conditions of changing climate. So we're going to ask ourselves, is the landscape still responding to the last great ice age? Is it still adjusting to the melting of the ice and disappearance of that ice about 15,000 years ago? Our aim is to do the highest level international science, quality science, to answer key questions about how our landscapes are going to respond to changing climates and how they've responded naturally to different climates in the past.
Of all the biogeochemical cycles, the carbon cycle is receiving particular attention because 60% of global warming is attributed to carbon-based radiatively forcing gases. Scotland has large stores of carbon-rich soils, and advancing our knowledge of the terrestrial carbon cycle is scientifically important. For example, how does land use influence fluxes of greenhouse gases and water vapour? And how will wetlands respond to warming and drying? SAGES Theme 2 brings together world-class expertise in characterising the carbon sinks and sources. And through field, laboratory and remotely sensed studies at a variety of different scales, these questions and others can be answered.
In the present context of global planetary warming, it has become crucial to be able to predict future climate change. Our climate results from very complex interactions between atmospheric circulation patterns and ocean circulation patterns. Furthermore, our climate is characterized by fundamentally non-linear dynamics, so it is prone to very rapid change. This is illustrated by archives of past climates in the past, which have shown that our climate was able to switch from one mode of operation to another very rapidly. Theme 3 of the SAGES programme brings together people from the paleoclimate community, atmospheric dynamicists, ocean dynamicists, in order to try and create a modelling community within Scotland who are going to try and resolve some of these questions.
The Centre for Earth System Dynamics is a research team dedicated to modelling the Earth system. It extends the predictive capabilities of research and encourages collaborations between scientists working on all aspects of the Earth system. This cross-disciplinary, integrative approach will help develop new research avenues into the poorly understood linkages and feedbacks between the atmosphere, ocean, biosphere and the solid Earth. The Centre for Earth System Dynamics forms the glue that allows scientists with different skills to view the Earth as a coherent system.
It's a nice piece of core, about 2 metres long, and round about here is 500 metres depth from the surface. And that's ice that fell as snow about 5,800 years ago.
The knowledge transfer programme of SAGES will focus on developing links with government, business and industry. A two-way link between SAGES and these key groups will ensure that the research carried out by SAGES members is informed by the needs of society. In return, the policymakers will have access to the best possible scientific advice. Sophisticated computer models will be capable of simulating mitigation and adaptation scenarios, assessing, for example, the impact of carbon reduction technologies. The graduate school will promote the integration of research activities between the SAGES partner institutions. Joint studentships and cross-institutional training will allow students to take advantage of the complementary skills offered by different institutions and to experience a wider range of equipment and techniques than may be available at their home institution. This approach will promote an effective Scotland-wide research environment for postgraduates.